But today we're super excited to be hosting the SeaAhead BlueTech Free Swim. And today we have Tom Birbeck of ArcMarine, Alessandra Bianchi of SeaTrac Systems, and they'll be sharing their stories. First, I'm going to pass it over to Taylor Whitkin, the SeaAhead desk manager at CIC Boston.
Great, thanks, Avi. My name's Taylor Whitkin. I'm the CIC BlueTech desk manager. Thanks everyone for being here. SeaAhead and CIC have partnered to run the first dedicated BlueTech innovation hub in Boston. Normally we have a central co-working and networking location for ocean entrepreneurs, growing businesses, investors, and corporations. It's also where we will be running our Blue Swell incubator in partnership with the New England Aquarium, which just launched this week. Convening in the same space right now is obviously on hold. So the BlueTech Free Swim is an opportunity to meet peers, exchange resources, discuss challenges, and get support. We're going to hear from Tom and Alessandra, and then we'll have a Q&A. I will throw it over to Tom to talk about ArcMarine.
Oh, thanks, Taylor. So good morning to everybody, or if you're from the UK like me, it's good afternoon. But thank you for everyone for inviting us. Today, I'm going to talk to you about ArcMarine and what we're doing to innovate in offshore wind. So to summarize, we solve a multi-billion-dollar problem for offshore industries around the world. We also make money from accelerating reef creation and ocean conservation. And we have found a way to turn offshore construction projects into ocean conservation opportunities. And that's what I'm going to be talking about today. So we've all seen pictures of the beautiful reefs that we fall in love with when we go scuba diving. And most recently the bad, the reefs that have been completely destroyed due to disease or overfishing and damaging fishing practices. But what a lot of people don't realize or know of is the ugly. And since the 1970s, offshore construction industries have been deploying these materials to protect subsea cables and subsea pipelines. And as you can see, they're often high CO2 concrete that's laced with plastic. They're either a 100% plastic mimicking seaweed, or they're used tires, which have now proven to be toxic, or they're literally plastic bags that are filled with rocks. And as such, the regulatory bodies who are monitoring the offshore construction activities deem these as marine litter, rightfully so. And as such, they've got to be removed at the end of that offshore construction project. Now, to give you an idea of the size of that problem, in the UK alone, we've deployed over 80,000 plastic-riddled concrete mats to protect oil and gas pipelines. Now, to recover that, each mat costs £11,000, and then you have to send it to landfill. It consumes 3.8 tons of diesel in actually recovering the mat back to shore. And it's a huge government and developer issue because 50% of the decommissioning cost is subsidized by our government in tax breaks. And that's a similar model that's being replicated across the world. So it's a huge financial problem for both the developer and the taxpayer. So for the past 5 years at ArcMarine, we've been developing a solution. And the solution was to replace these marine littered products with a low CO2 eco-friendly alternative to give us every opportunity to construct massive marine protected areas around offshore construction projects and leave a positive marine legacy, and at the same time completely eliminate decommissioning costs from subsea protection. So for what we've done, we've invented Reef Cubes, which is called the patented building block for the ocean. And they're modular and flexible, and they're suitable to a wide range of applications. Now, we've had many animals lay their eggs on them to prove that they're a nursery and spawning ground, such as cuttlefish, sharks, squid, to name but a few. And we've also had commercial fish stocks like edible crab, brown lobster, cod, and bass all use our structures, which help boost commercial fish stocks in that area. We're currently manufacturing them in sizes as small as 15 centimeters, but sizes up to 1.5 meters that weigh up to 5 ton. And we're currently manufacturing them to 2 meters that may weigh 10 to 15 ton, and that's to act as a 24/7 bottom trawling deterrent for around marine protected areas. So as you can see, the impact is immediate from when Reef Cubes go in. So the Reef Cube on the left with the anemone was subsea for about 6 months. And going down the line, it's 6, 12, 18, and then the top right corner is about 24 months. So there's many other applications for reef cubes, such as ecotourism, sustainable fishing and aquaculture, coastal defense, and coral and mangrove plantation. But for this topic, I'm going to stick on offshore wind because that's sort of what we're focused on. And you might be thinking, well, how is what you do eco-friendly if you're using Portland cement? Because that is a huge contributor. In fact, it's 8% of the global emissions go on Portland cement. So one of our key areas of innovation was to completely move away from any Portland cement into our mix. We've currently achieved a 90% CO2 saving compared to Portland cement. But last week we achieved a huge milestone in the company, and we reached carbon neutrality in our product. And we actually believe that we could end up being carbon negative as a rule of thumb by the end of this year. So it's something that we're really proud of. We also use 100% recycled materials into the mix as well. So all the sand and stone that goes into reef cubes is normally a byproduct used from the mining and quarry industry, which is seen as waste material, but it's completely clean and environmentally friendly. So in terms of our customers, on the left here, we have aquaculture. So we're part of a large aquaculture government-funded project in Devon, which is showing the co-location of reef cubes around a scallop farm, a scallop hatchery. In the middle there, we have offshore wind. So we have confirmed pilots with Vattenfall in the UK, with Tenant around a substation in Holland, and that's run by a project called Director of SeaTrac, or in English translates to the Rich North Sea. And that's specifically looking for oyster restoration and sharks and cephalopods and rays habitat restoration. And ArcMarine have manufactured the units, and if it wasn't for COVID, they'd already be shipped. But we're hoping to ship them by the end of the month or by July, and then they'll be deployed in August, September in the Dutch North Sea. We've also applied to the Oil and Gas Technology Centre based in Aberdeen, and that's to speak to BP and Shell in regards to a oil and gas pilot based in Aberdeen. But we're also looking for customers abroad as well. So to give you a quick lowdown of the projects, ReefAS is the reef enhancement for fisheries and aquaculture sites, and that's improving the co-location of wild catch fishers and aquaculture owners. We're also trying to protect the seabed from damaging scallop dredging, which was happening in the area. And the overarching aim is to improve biodiversity and encourage sustainable fishery management. So for the Rich North Sea, the stuff that's going around Tenant, the products that go around Tenant, this is a reef cube formation that was specifically designed to cater for sharks, octopus, squid, and rays. And it was used by ecologists from Holland and ArcMarine to come up with these designs. And we've got 14 of these structures being deployed, hopefully by August, September. So who pays and why? So all of these blue chip clients are going to be our customers. And the main driver for them is going to be the removal of the decommissioning costs that I mentioned. That will completely be wiped off their balance sheet, which is a huge incentive. But what we're witnessing in Europe is that there's now becoming a actual mandatory government legislation to improve the marine environment in which when you're building offshore wind farms. So it'll actually become a mandatory reason to get a license to operate. And that will mainly be driven by CO2 reduction policies which are coming in, and to achieve net zero carbon, and also to remove any plastic pollution that's going in around these wind farms. And at the end of it, they also benefit from the huge positive marine legacy, which isn't what the oil and gas industry are actually dealing with now, which is this horrible, horrible instance in which they're decommissioning structures and leaving plastic subsea. So offshore wind can actually avoid that from the offset. To give you an idea of the size of the market, the 2050 vision by Europe is to achieve 450 gigawatt of wind. Now, the subsea protection for 1 gigawatt of offshore wind normally is about $12.8 million. So as you can see, Europe, China, and USA are our biggest market. Being a European-based company, obviously our first traction was in Europe. But although China is the bigger market, our main focus is actually on the States, because we see ourselves aligned with the US a lot more in terms of environmental capabilities and environmental vision compared to China. So something that we want to do this year, or at least early next year, is get into the US market. In terms of competition, you may know of Reef Ball on the left-hand side. They're a US-based company, and eConcrete, who are Israeli-based. However, none of them are proven scour protection or subsea protection at all. In fact, some of them have failed in physical modeling experiments, which is why we're being trialed in Holland and they're not. We're also the only one that is plastic free, and we're the only one that is 100% Portland free. And we've got 2 patents granted in the UK and pending in the EU, USA, China, Japan, South Korea, Australia, Saudi Arabia, India, Brazil, and Mexico. And that, I think, highlights our global ambitions for the company and where we see this going. We need to be in every single offshore construction project around the world to make the maximum impact for the marine environment. As for our team, so myself, Tom Birbeck, commercial diver is my background, and several years in aquaculture before I turned my hand to ArcMarine. But we also have managed to bring people over from the dark side, from oil and gas. Steve Wright and Colin Black, 37 years of oil and gas experience as managing directors for companies, and have also worked below the likes of Shell, BP, Exxon. But we also have 75% of our team as scientists from the universities of Southampton and the University of Plymouth. So a really well-rounded bunch, from subsea diving and engineering to science and to business commercialization and consultancy. So that's me. We're looking to get in touch with people for projects, live projects that we can be part of, partnerships in the US who can help us manufacture Reef Cubes abroad. And as a startup, we're also always looking for investment. So yeah, that's me in a nutshell. Thanks, guys.
Thanks, Tom. All right, Alessandra, you ready?
All right, thank you everyone for this opportunity. My name's Alessandra Bianchi. I am the resident liberal artist in a company of techies, SeaTrac Systems. We make solar-powered autonomous surface vessels, unmanned surface vessels. There are the co-founders. On the left, Buddy Duncan. On the right, Jigger Herman. They are old, my mic is a bit high, is that better? I call them old sea dogs. They're MIT naval architects. They met 30 years ago in the hallway of MIT, and the rest has been history. They've started 2 companies successfully back to back. And you can see on our website what those are, but basically they grow their companies for 10 years and then they sell them to a larger competitor. They are happiest when they are solving nasty technical problems and delivering efficient, cost-effective, frugal solutions to their customers. Let's see, next slide, please. We are in Marblehead, Massachusetts, which is one of the oldest sailing fishing villages in the United States. The globalists in the room might be amused to know we have more 1600, 17th century houses standing than any village in the country. So it might seem anachronistic to have a high-tech company in a historic seaside town, but the sailors in town will tell you otherwise. That everyone here loves messing about with boats. This is a picture of our prototype boat a few years ago with an image flow cytobot bolted to the bottom that we measured harmful algal blooms with a Woods Hole biologist. And in the new iteration, this machine will be housed inside the boat, but let's keep going. And you'll just have to bear with my scattershot liberal arts explanations here. I would love directed questions at the end, and Buddy and Jigger are currently hunched over the production model, bringing it out as we speak, but they are very happy to entertain technical questions. So SeaTrac, they studied the market and decided that there was a role for a efficient, cost-effective, and more simple vessel compared to some of the other flavors of surface vessels out there. You can see their background I alluded to, MIT, early work for the America's Cup. Their first 2 companies, the first one was computer-controlled fabric cutting. It grew to be Marblehead's largest employer. It grew fast and made the Inc. 500 number 86. The second company in the smart home arena, 10 years before the Internet of Things, I'll jump to the current company. The current company, the ASVs, are designed to go for months at a time. The gating item is biofouling. We are targeting, let's see, can we go to the next slide? Well, we're targeting researchers like woods hole biologists, commercial, military, excuse me, and commercial, and the applications you can see. I'm sure there are those of you in the audience who can explain this better, but acoustic monitoring we feel is a good application for offshore wind. Mammal management, there are, as you know, legal requirements that must be met before you can put anything in the ground. So we have been testing out towing hydrophones and using mammal identification software to match what you're hearing. We've entered some RFPs from some of the wind farms competitions. We're waiting to hear. There have been some delays, but we look forward to trialing this option. Next slide, please. Environmental monitoring. Similarly, we have done projects for Department of Marine Fisheries, Coastal Zone Management, measuring eelgrass health. We've done the harmful algal bloom. We are measuring water quality for the EPA closer to where we are on the North Shore of Boston. And so we feel that these are all jobs that wind farms need to take into account as well. Next slide. Surveys, tower scour monitoring, multi-beam side scan. We have, our boat is designed to have up to 500 watts of power, 100 watts continuous based on sunlight in March in Boston. So we feel that we have enough power to successfully keep these sensors going for weeks, months at a time. There's sophisticated software in place to ration out the amount of power the sun that's collecting, and our numbers compared to some of the other flavors of surface vessels out there, we think are quite compelling and competitive. Next survey, or next slide, please. Here's the, for offshore wind farms in particular, we came up with this whale Sentinel, and we entered a global competition called the Ocean Alliance, and we were, of 50 worldwide applicants, we got down to 5 semifinalists, and we enjoyed the process immensely. We didn't win the competition, the $100,000, but the exercise of coming up with this idea and getting feedback from the Aquarium, Conservation Law Foundation, Dr. Ian Kerr of Ocean Alliance up in Gloucester, who was the inventor of the SnotBot. It was a very valuable activity, and we have this idea in some RFPs right now. So we are hoping for traction on that, and we welcome inquiry from all of you. Let's see, I'm gonna get to the boat a little bit more. So you can tell I'm not the naval architect, but here is the new production model. Buddy and Jigger built a prototype starting 5 years ago, and it has been sort of quietly doing missions for the Navy, for scientists, for others for 3 years, learning what it did well and what needed work. And so here is the new and improved production model that is starting to come out of our shop literally this week. We've been in a quiet period, and then COVID slowed things down a bit, but now we are taking orders, delivering orders. Our surface vessel is designed to go very, very shallow, as shallow as 42 centimeters draft, 1.4 feet, or out in the open ocean where it can be washing machined and survive Beaufort 11 in theory. We are going to run tests on it. We've done some testing, but we're going to do more rigorous testing in the very near future. You can see the features here. It's 4.8 meters long. We call this the SeaTrac SP48 for solar powered 4.8 meter, 15.75 feet. The self-righting keel, the large payload bay, the antenna for which you can mount LiDAR, for instance, can measure wind speed of offshore wind turbines. The boat comes with a variety of onboard sensors: wind speed, direction, air temperature, air pressure, water temperature, surface water current, speed and direction, boat heading, speed through water, GPS location, speed and direction, and an AIS transponder. One of our first customers, a professor down at Mississippi State University, wants a camera on it and a stereo system to alert or to deter people who might be approaching. So those are in the works as we speak. Simple, reliable, cost-effective is their mantra. Let's see. Can you go to the next page, please? Okay, so we're sensor agnostic, and here is just a sampling of all of the various sensors that they have designed the boat to support and power. I probably am not going to touch discussing the particulars of these sensors, but happy to take questions afterward and happy to direct you to Buddy and Jigger. But the ADCPs, the IFCBs, hydrophones. All right, keep going. Okay, so why SeaTrac? We are designed to go out in the ocean and do jobs that are dirty, dull, dangerous, or too expensive to do with boatloads of humans the way they've been done historically. We don't want to remove the human boats. We just want to supplement and complement and be a force multiplier. You can see some of our highlights that we think differentiate us from others down below. Cost is a very big one, not spelled out in these slides. We feel that we are half to a third the price of some of the competitors. And unlike some of them, we can go out in any weather. We don't need wind or waves to propel us, for instance. We have a quiet brushless motor on the back. And let's see, I had one more thing, forgive me, and I'm having a senior moment. Well, at any rate, we are actively welcoming partnerships, proof of trial concepts. We'd love to have anyone come to Marblehead. Yes, there are batteries inside of this. I see a question. Lithium ion. There's sophisticated battery management system, navigation system, and communication system. Maybe we should go back. Let's see. Well, the boat offers 3 ways to communicate. Short burst data, line of sight RF, cellular, and 3 flavors of satellite, Rudix, Certus, and, oh, the short burst data, excuse me. I think I'm gonna stop here and look forward to your questions. Thank you very much for listening.
Thank you, both Alessandra and Tom, for your presentations. So we'll move into the Q&A. So Tom, there were questions in the chat wondering a couple of things about the details of the cubes around, you know, what they're made out of if the material is not cement, and how much they cost. How should people think about the cost of these and what's in them?
Yeah, it's a good question. So we use a range of materials that come from a family called geopolymer cements. So there's no Portland cement. It's It's hard to say because it is proprietary, but it's it's a non-Portland cement mix, which is being tested to make sure it doesn't have any trace metals, heavy metals, or leach anything toxic. We've also started tweaking the pH to make sure it achieves pH neutrality pretty quick, which helps the adhesion. In terms of price, it really is dependent on the amount of cubes that are bought and where they are. So we're currently manufacturing in the UK, but we can manufacture abroad, and then it sort of depends on the local supply chain as to some other raw materials and what the finished cost is. But to give you an example, we can sell Reef Cubes for as little as $100. But then there's obviously the deployment, the transport, and everything that goes along with it. The units that I showed you for the Holland project, they were about €2,000 each.
For a similar perspective, with Alessandra, there's a number of questions around when your first boats will be ready and how much the models will cost, etc. All right, hold on.
Good questions. The first few boats are spoken for, and we anticipate, I think everyone can hear me? Yes, thumbs up? You can hear me. Okay, just Alyssa's muted. Our customers are going to take delivery of those in early August, late July, and we are fast and furiously making a fleet of 6 to send out on trials and tests. The base price is approximately 130, 140K, which we think compares very competitively to more higher priced options. We also will rent these boats by the day. We have some figures where some of the competing boats are 5,000 a day, 2,500 a day. Ours are going to be $500 per day, approximately. It depends with sensor integrations and how much you want our team to execute the mission or not. But right now, we're working hard to be cost competitive. I didn't mention another differentiators that we can go 4.5 knots top speed, and depending on, if you are a surveyor up in the Bay of Fundy and you're racing the ice coming back in, sometimes speed might help you. So we think that seems to be a popular feature as well. Let's see. Other things I didn't mention is that we allow a mix of control and autonomy. You can control it completely on your own. We can have a man in the loop for supervised autonomy. Full autonomy, you can change the mission on the fly. There are built-in collision avoidance behaviors. Station keeping is fine, very tight radius turning if you're mowing the lawn, for instance, going back and forth on a mission. There is a data sheet. I'd be happy to, well, it's on our website, and we have missions on our website that we've done with, again, Woods Hole and the Navy SEALs and the EPA, and you can look specifically at some of those things that our boat has done. But the data sheet in particular is also on there with the specs.
You could put the links in the chat, and then everyone can see them.
Excellent. Okay.
All right.
Thank you.
Thank you. I think related to that, though, would be a question that I've got that came up around the discussion of your marine mammal ID systems, and it does. This is a big problem and a big question for both the offshore wind and the maritime community, as to how to better interact with the marine mammal life and to avoid hitting, right whales are a big problem. They're nearly extinct in the in the region that we're from. And so and there are problems in other areas as well with other whale species. And so I was wondering how you're thinking about partnering on that problem set. Is SeaTrac planning on making its own software to develop that problem, or do you have partnerships to approach that?
I think right now we are chasing so many opportunities that that would be a nice to have, but not a need to have at this moment. We're looking for partnering, and I know there are Woods Hole scientists on the case. There's a long history of trying to do this in a mammal-friendly way. There are stationary buoys, acoustic buoys, pingers in Boston Harbor, for instance, and those are wonderful, but you have to hope that the whales swim by them. We've spoken with Priscilla Brooks of Conservation Law Foundation, who really like the idea of becoming a whale sentinel, like a chaperone. The whales have very predictable migration patterns from Florida all the way up to Canada every year. And if you could support, 3 to 6 of our boats accompanying them as they swim up the coast and listening and then pinging out and alerting ships and offshore wind builders. There's infrastructure in place already, the Whale Alert phone app, where boaters, shippers, fishermen, civilians can, on their app, say they've seen one, and then that goes into their algorithms and they put it up on the map. So there are pieces in place already that we hope to leverage, but we feel we can have, our big contribution will be the boat at first, and towing a hydrophone on it sufficiently. But yes, the software is a key need.
Great, thank you. Well, we may know some other folks working on that technology, so let's chat afterwards.
Excellent. Well. Okay.
Yeah, that's what we're doing here. So, so great. And I think similar to that question about the intersection of offshore wind and innovation in other areas. Tom, I was wondering if you might talk a little bit about whether or not your technology could have any effect on the tensions between offshore wind and the fisheries industries. As you may know, that's a big issue for the U.S. Northeast, and would love to understand if this could contribute in some way to that challenge.
Yeah, definitely. Marine spatial planning, co-location is going to be a huge upcoming problem as we try and advance offshore wind, and we're already witnessing it in Europe. What our concept is with Reef Cubes is that offshore wind farms close the area to fishing primarily because they have subsea assets on the ground like cables, which they don't want to be damaged during trawling. And if what we can do is protect these cables and create a nursery and spawning ground, which will actually help proliferate their catch, and they can actually benefit from the overspill, there's almost a trade-off where we've closed that area to fishing, but you will be benefiting from the overspill catch, which will be generated from that productive reef. So that's one angle that we're going down. The second option that I would like to see personally is an offshore wind farm operator, perhaps even going a step further, to say we will either build you a reef that you can fish for the area that we've taken up, or we will actually integrate a restocking program during this closed area. So for instance, if we take a wind farm in the UK, that area is closed for 30 years as part of the licensing. And what we could see then is the operators say, well, what we'll do is we'll release 8,000 juvenile lobsters every year for the next 30 years around our turbines. And when we take the turbines out and we leave that area, you'll then have a vast abundant reef that could then be fished sustainably. And I think that's the big argument, is if we're going to close these areas to fishing, they need to be fished sustainably so we don't have these problems again, and then they can actually be reopened slowly and monitored from the get-go. But the short answer is yes, definitely. Reef cubes are a compromise between the fishing industry and offshore construction.
So I'd just like to thank both of you. Both SeaTrac and ArcMarine are SeaAhead startup members. If there are any folks with technologies that are applicable to offshore wind in the room, would love to chat with you as well to learn about them.